Hi guys, we are doing inverse trig today. Inverse trig is you're basically using the unit circle the opposite way. Okay, so it says inverse trigonomic relations enable us to find angle measurements when given the value of a trigonometric function. Okay, so the way it's notated is with that -1. So sine to the -1 of A is read the inverse sine. Okay, so cosine to the -1 is read inverse cosine. Tangent to the -1 is read inverse tangent. Okay, and that exponent of -1 indicates the inverse of and not the reciprocal of the function. Okay, so if it says tangent inverse of A, that does not mean cotangent of A. Does not mean. Okay, we will talk about what it means, but it does not mean a reciprocal. Okay, so let's start by evaluating these the way we know how to. So number 1 says sine of 120 degrees. Okay, and we know that if it says sine of 120 degrees, we go to 120 degrees. Okay, and since it says sine, we want the y value of the coordinate. So sine of 120 degrees is √3/2, because that's the y coordinate there. Number 2. Actually, I'll write number 2 below it. Okay, number 2 is cosine of 240 degrees. Okay, so again, the way you would normally find that is you go to 240 degrees. Since it's saying cosine, it wants the x value. So it's that x value at the coordinate at 240 degrees. So that equals -1/2. Okay, and number 3 says tangent of 315 degrees. Okay, so again, you go to 315 degrees, and tangent is the y coordinate divided by the x coordinate. So it's -√2/2 divided by +√2/2, which is -1. Okay? All right, so let's talk about inverse. Okay, so remember the inverse is going the opposite way. So yes, sine of 120 is equal to √3/2. Well, the way to use it as an inverse, you'd say inverse sine of √3/2 equals 120. Okay, here you'd say inverse cosine of -1/2 equals 240. Okay, it's just the opposite. Inverse tangent of -1, inverse tangent of -1 equals 315. Okay, that's just what we're doing. We're doing the exact opposite. All right, so let's evaluate each inverse trigonometric relation. Find all the possible values between 0 and 2 pi for each. Okay, so there is a little twist to this inverse, okay, because you can get multiple answers, and I'll show you why. So number 1 is inverse sine of 1/2. Okay, so again, you're going the opposite way of what you were doing before. So you go to the coordinates first. So what coordinate has a sine of 1/2? Okay, remember sine is the y value. So what coordinates have a y value of 1/2? Okay, maybe I should write that down. Okay, so that's what you're looking for on your unit circle. Okay, so y equals 1/2 here. Y equals 1/2 here. Y equals negative 1/2 here, but we're looking for positive, so that doesn't count. Same thing for that one. That doesn't count because it's negative. Okay, so the degrees or the angles that have a sine of 1/2 are 30 degrees and 150 degrees. And that's how you would get two answers. Okay, so let's do number 2. Number 2 is inverse cosine of root 2 over 2. Okay, so since we're talking about cosine, I want the x value. So it's asking basically what coordinate have a x because cosine equal to root 2 over 2, positive root 2 over 2. Okay, so again, we go over here. X coordinate equals positive root 2 over 2 here. And here. Okay, so 45 degrees and 315 degrees. Okay, and on the notes, it also gives it in radians. Like 45 is pi over 4, and 315 is 7 pi over 4. So just if it asks you for it in radians, give it in radians. If it asks you for it in degrees, give it in degrees. And actually, in the directions, it says find all of the possible values between 0 and 2 pi for each, which is indicating that you should be using radians because it's got 0 to 2 pi instead of 0 to 360. So actually, this would be more correct. And in number 1, pi over 6, because pi over 6 is 30 degrees, and 5 pi over 6, because 5 pi over 6 is 150 degrees. Those would be more correct than these. Okay, so just be careful of that. All right, number 3. Inverse tangent of root 3 over 3. Okay, so you want to look for the coordinate where your y over x equals root 3 over 3. So you're going to have to probably do a little bit of math for these tangent ones. Okay, and actually on my unit circle that I regularly use, I have the tangent of each, because obviously this is the sine, this is the cosine. The tangent you have to calculate. So on the unit circle that I regularly use, I have the tangent value next to the coordinate, next to each coordinate. So like this tangent value would be 1/2 divided by root 3 over 3, which is 1/2 times 3 over root 3. Oh, no. Sorry, wrote it wrong. Root 3 over 2. So these would be 1 over root 3, which would rationalize to root 3 over 3. Okay, so on the unit circle that I regularly have, I don't have the work on it. I just have a root 3 over 3, because that just tells me that the tangent of this is root 3 over 3. Okay, so you may want to have that for yourself as a little tool, a little shortcut. And you only have to find the tangent of the first quadrant. Okay, so root 2 over 2 divided by root 2 over 2, which is itself, is 1. So tangent here is 1. And root 3 over 2 times 2 over 1 is just root 3 over 1. Okay, so the tangent here is root 3. And then you can go to your other, remember, all students take classes. So in the first quadrant, all of the trig functions are positive. In the second quadrant, all of the only sine is positive. That means tangent is negative. So remember, the ones with the same reference angles are mirrored. Okay, so this is negative root 3 because this is mirrored to this. Okay, this is negative 1 because this is mirrored to this. And this is negative root 3 over 3 because this is mirrored to this. Okay. And then you can do your third quadrant. Okay, this is, in the third quadrant, your tangent is positive. So all of your tangent values that you'll write are positive. So this will be positive root 3 over 3. This will be positive 1. And this will be positive root 3. Okay, and in the fourth quadrant, only cosine is positive, so tangent is negative. So again, we're writing negatives. Okay, so I have that in my unit circle that I use regularly for class and for homeworks and stuff like that. Please feel free to do that as a little shortcut. Just make sure you know how to do that for tests and quizzes. Okay. All right, so let's continue. So we were looking for inverse tangent of root 3 over 3. So I'm looking for where the tangent is equal to root 3 over 3, which is here and here. Okay, so 7 pi over 6 and pi over 6. Okay. Number 4, we have inverse cosine of root 3 over 2. So again, cosine is the x coordinate, so we want to know when the x coordinate is equal to root 3 over 2. Okay, so x coordinate equal to root 3 over 2, that's here and here. So pi over 6 and 11 pi over 6. Okay, let's also do number 5. We have inverse tangent of inverse tangent of 1. Okay, so over here on the unit circle, when I wrote my tangents, I actually have not written my tangents for the 4 axes. Okay, and yes, those still have tangents. So let's go over what the tangent value of those are. Okay, so the first axis point is the one on the right. It's at 0 degrees or 360 degrees or 0 or 2 pi radians. Okay, so here your tangent would be your y over your x. So your y coordinate is 0, your x coordinate is 1. 0 divided by 1 is 0. Okay, so my tangent value is going to be 0 here. All right, at the top, at pi over 2 radians or 90 degrees, we would do our y over x again. So y over x. Okay, so 1 over 0 is actually undefined. So there is no tangent value here. So anytime it asks you for the tangent value at pi over 2 or 90 degrees, it would be undefined. Okay. At pi, or 180 degrees, y over x, okay, that would be 0 again. And then at the bottom, at 270 degrees, or 3 pi over 2 radians, your y over x would be undefined again. Okay, so our tangent value down here is also undefined. Okay, so when we're finding inverse tangent of 1, when is my tangent equal to 1? That's here and here at pi over 4 and 5 pi over 4. Okay, and then number 6 would be inverse sine of 0. Okay, so when is my sine value or my y value equal to 0? Okay, well that is here and here. Okay, so we've got 0, pi, and you can even say 2 pi. Okay, so that's inverse trig functions. Now let's get into inverse functions even more. So the next page says, since more than one value of theta gives the same output value for a given trig function, so what it's saying is that it's giving 2 answers, sometimes 3. We must restrict the domain, so we only get 1 answer of the trig functions in order to define inverse trigonomic functions. The trig functions with a restricted domain are indicated with an uppercase letter. The inverse trigonometric functions are also called arc sine. Okay, so anytime it says, inverse sine, or arc sine, we have to restrict the domain to negative pi over 2 to pi over 2. Okay, so if we look at our unit circle, if we look at where negative pi over 2 is and positive pi over 2, so negative pi over 2 is actually right here, okay, because that's in the negative, because positive pi over 2 is here. So that means negative pi over 2 would start here and go in the negative direction, the same distance as pi over 2. Okay, so that's here. Okay, so the restricted domain is from negative pi over 2 all the way to positive pi over 2. So only the right side of the unit circle. So what that means is when it's asking for inverse sine with a capital letter or arc sine, you're restricting the domain and only getting your answers from the right side of the unit circle. Okay, that's what that means. When it says cosine with a capital C, or arc cosine, okay, its domain is restricted to 0 to pi. Okay, so let's look at the unit circle. 0 is here, pi is here. So from 0 to pi. So in that interval, you will only get your answers whenever it's asking for inverse cosine with a capital letter or arc cosine. Okay, that's the only place you will get your answers. You will not look at the bottom. All right, and now let's look at tangent. When you got arctangent, or tangent, inverse tangent with a capital letter, your restricted domain is the same as sine. Okay, so again, from negative pi over 2 all the way to pi over 2. Okay, so when it's asking for inverse tangent with a capital T or arctangent, you will only get your answers from the right side of the unit circle. Okay, so let's practice real quick. Let's see. So evaluate each inverse trigonometric function. So number 1 says inverse cosine with capital C of 1/2. Okay, so again, that means we're only looking on the right side. So we're only looking from negative pi over 2 to pi over 2, which is the right side. Okay, so inverse cosine of 1/2, so we're looking for whenever the x-coordinate is positive 1/2. Oh, no. We're looking at, oh, I made a mistake. Hopefully you guys caught on to that before I got here. But cosine, sorry, cosine, it's not this. I messed up. Cosine is from 0 to pi. It's the top. Okay, it's the top side. Sorry. All right, so if we're looking at inverse cosine of 1/2, again, we're only looking at the top, so only in the green shaded area. When the x value is 1/2, happens right here at pi over 3. And as you can see, if you only look at the top half, there's only one answer. Okay, over here, the 1/2 is negative, so it's not that one. So we restricted it to one answer by only looking at the top half of it. Okay, so it's equal to pi over 3, and just pi over 3. Okay, or you can say 60 degrees again, because 60 degrees is the same thing as pi over 3. All right, let's look at number 2. Number 2 is inverse sine, capital letter, meaning you have to restrict that domain. Okay, so we're only looking from negative pi over 2 to pi over 2. Okay, and again, that's just the right side. Okay. So sine is the y coordinate. So I want to know when my y coordinate is equal to root 2 over 2, just on this right side. Okay, positive root 2 over 2 is right here. So pi over 4 is my answer. Okay, and also you can say 45 degrees because they are the same angle. Okay? All right. Let's move on to using trig functions to find each measure of theta on a triangle, okay? Because these are helpful. Inverse tangent, inverse trig functions are very helpful whenever you're looking for a missing angle on a triangle. Okay, so for example, this is on the last page of the notes. If you're looking for theta and you're given these side lengths, and you're looking for theta, which is an angle, okay, you've got the adjacent to your theta and the opposite to your theta. So that means you're going to be using tangent. So tangent of theta is going to equal 8.7 over 4. Well, how do you find the angle measure theta? You're going to use your calculator and you're going to find the inverse tangent of 8.7 over 4 to get your theta. Okay, so watch. All right, so you'd hit second tangent because that's your inverse tangent, and then 8.7 divided by 4, and I'm going to make sure, oh, I'm not in degree mode. Make sure you're in degree mode. Okay, so you should get 65.3 degrees. So theta equals 65.3 degrees. Okay, and then in the second one, again, your theta is missing right there, and you got 12.5 here and 13.9 here. 12.5 is your adjacent, and 13.9 is your hypotenuse. So you would use cosine. So cosine of theta equals 12.5 over 13.9. So to find theta, you'd use inverse cosine. To get your theta. Okay, so in your calculator, you do second cosine, which gives you your inverse cosine of 12.5 divided by 13.9. And you'll get 25.9. Okay?